Welcome to qnawire.
Here we have a composite function, a function inside a function, and the inside function is a quotient. So we're going to end up using the chain rule to take care of the composite and the quotient rule to take care of the derivative of the inside. So here we go. So first of all, the derivative of the outside function, which is the fifth power function, would be to bring down the 5 and then raise the inside to the fourth. Now we're going to multiply that by the derivative of the inside. So here's where the quotient rule comes in. So we have the bottom, y squared plus 1 times the derivative of the top, 4y cubed, minus the top, y to the fourth plus 1 times the derivative of the bottom, 2y, over the bottom squared, y squared plus 1 quantity squared. And now we're going to simplify. Okay, so I'm going to write this quotient here as the top to the fourth over the bottom to the fourth. So we have 5 times y to the fourth plus 1 to the fourth over y squared plus 1 to the fourth. And I do that because I suspect that some things are going to simplify as we go. Some things are going to cancel. For example, we can already see that the denominator of the second fraction has some terms that will cancel with the numerator of the first fraction. Or actually, they will combine with the denominator of the first fraction, Okay, so now we want to simplify our numerator of the second fraction. So we're going to distribute the 4y cubed, multiply it by both of those terms, and distribute the 2y, multiply it by both of those terms, and distribute the negative. So we have 4y to the fifth power plus 4y cubed minus 2y to the fifth power minus 2y. All right, now let's see what we can do with that. Notice that we have 4y to the fifth minus 2y to the fifth, so we can combine the like terms, and we get 2y to the fifth. And we're going to have to create a little bit more space to work here. All right, so this is what we just saw a moment ago. And what we're doing now is we're combining the 4y to the fifth minus 2y to the fifth. So now we have 5 times y to the fourth plus 1 to the fourth times 2y to the fifth plus 4y cubed minus 2y over, now let's go ahead while we're rewriting this and combine these into y squared plus 1 to the sixth power. Okay, finally, let's notice that each of the factors, or each of the terms in the final factor of the numerator is a multiple of 2y. So let's factor 2y out of each of those, and we'll multiply that 2y that we get factored out by the 5. So that will give us 10y times y to the fourth plus 1 to the fourth times y to the fourth plus 2y squared minus 1. And that's still over y squared plus 1 to the sixth power.